Let's imagine you're standing in front of the most advanced computing system on the planet. 40 petaflops of raw power. That's the same performance as the Sierra supercomputer from 2018, which packed in 18,000 Volta GPUs. But here's the kicker. This single node replaces that entire supercomputer. We're talking about a 4000-fold leap in just 6 years. A jaw-dropping demonstration of Moore's Law in action. AI computing has been scaling at an astonishing rate, about 1 million times every decade. We're not just talking about faster chips anymore, we're talking about entire data centers becoming single unified computing units. The data center is now the new computer, running colossal jobs under a revolutionary operating system. 3 years ago, Hopper changed the game, becoming the world's most recognized AI computer. But we didn't stop there. The next frontier, inference time scaling, AI that doesn't just spit out answers in one shot, but reasons, iterates, and thinks fast, just like you do in your head. That's where Grace Blackwell comes in. Grace Blackwell is built to scale up, turning a computer into a giant, and scale out, connecting many giants together. Scaling out is relatively straightforward. Scaling up, that's insanely hard, pushing the limits of semiconductor physics. But Grace Blackwell does it, and it's already available on platforms like CoreWeave with production ramping up everywhere. Every year, like clockwork, we upgrade our platform. This year, in Q3, we're rolling out the Grace Blackwell GB300. It fits into the same chassis as before, but inside it's all new. 1.5x more inference performance, 1.5x more HBM memory, and double the networking bandwidth. Let's peek inside. The GB300 compute node is now 100% liquid-cooled, but otherwise, it slots right into existing systems. The real magic is how we've pushed chip design further, connecting 2 massive chips using a new TSMC process, and then tying everything together with NVLink, the world's fastest switch. One NVLink spine, 70 pounds of precision engineering, moves more data than the entire global internet at peak traffic. This architecture lets every GPU talk to every other GPU, all at once, with 130 terabytes per second of bandwidth. To handle this, everything sits in a single rack, drawing 120 kilowatts and cooled by liquid. We've essentially turned the whole rack into one giant motherboard. But we don't stop at racks. We build AI factories, massive purpose-built data centers like CoreWeave, Oracle Cloud, and xAI's Colossus factory, each a gigawatt-scale investment. These are not just data centers, they're the assembly lines of the AI era. The more you build, the more you can make. Today we're announcing NVIDIA NVLink Fusion for custom ASICs. This is a breakthrough for anyone building semi-custom AI infrastructure. Now you can mix and match CPUs, GPUs, and custom accelerators, all tied together with NVLink Fusion chiplets. This opens up the entire NVIDIA ecosystem for integration, letting you scale up your own AI supercomputers. Let's talk about new product categories. For developers, researchers, and students, we're launching the DGX Spark, a desktop AI supercomputer. It delivers a petaflop of performance and 128 GB of memory, all in a unit you can keep by your desk. That's the same power as our 300-pound DGX one from 2016, now shrunk down to desktop size. Need more muscle? The DGX Station is the most powerful AI computer you can plug into a wall outlet. Enough to run a trillion-parameter AI model right in your kitchen. Just don't run the microwave at the same time. For enterprise, we're introducing the RTX PRO Server, a powerhouse that can handle any workload from AI agents to graphics to video. It's powered by 8 Blackwell RTX PRO 6000 GPUs, all connected by a new switched motherboard for blistering east-west traffic. Now, let's talk about robots. AI agents are essentially digital robots. They perceive, understand, and plan. But we're also building physical robots, starting with the Jensen Huang processor and the Isaac platform. Training these robots requires a massive amount of synthetic data, generated through human demonstration and amplified by AI. This is the era of agentic AI, where we need enormous compute for both training and operation. Humanoid robots are especially important. They can work anywhere humans do, fitting seamlessly into our world. As we build more robots, we need digital twins, virtual replicas of robots, equipment, and entire factories. Omniverse makes this possible, letting us simulate, design, and optimize before anything is built. The world is investing $5 trillion in new plants over the next 3 years. Digital twins will be key to building these efficiently and preparing for a robotic future. In summary, we're not just creating the next generation of IT, we're building a whole new industry. The opportunities ahead are extraordinary, and we're excited to partner with you to build AI factories, deploy agents, and design the robots of tomorrow. Thank you for joining us. Here's to an incredible future at COMPUTEX.